Okay, so calculate the mass of cyclohexene that would be formed if all of the cyclohexanol um, is converted into cyclohexene. Now let's make sure that we don't get confused with what's what here. So we'll use this highlighter again, where this is the cyclohexanol. So if all of the cyclohexanol is converted into cyclohexene, let's use pink for cyclohexene, and we want to know the mass of the cyclohexene if all of the cyclohexanol was converted into cyclohexene. The trick here is to work out, to look at the balanced equation, there's cyclohexene, and note that the ratio in terms of moles is 1 to 1. Okay? Incidentally, we can see it's told us here that the number of grams is 1.8 grams, but we're not going to use that in this. That's probably going to be useful in a later question. So we just want to know if, and I often say this is an important word in moles question, this word if. They're leading you through this nicely here. So if it had all been converted, okay, so the first thing we need to notice is that, it's a 1-to-1 ratio. If we've got 0.06 moles of the cyclohexanol, we're going to get 0.06 moles of cyclohexene, okay? So what do you think you would do? Yeah, what do you think we do next? Okay, yeah, so the first stage is going to be to work out the molar mass. That's the molar mass of the new product that's on the cyclohexene. We already know the molar mass of the cyclohexanol, and we even know the number of moles of the cyclohexanol. So this is the molar mass of cyclohexene we're working at here. So the molar mass of cyclohexene is 82 grams. If we had 1 mole, we would get 82 grams. But what would we have in this case? We don't have a mole of it. We know how many moles we've got. We've got the same amount of moles as the cyclohexanol because we're assuming that all of the cyclohexanol has reacted in this scenario. So how many grams would that be then? So we know that we're going to have because it's a 1-to-1 ratio, we know we're going to have 0.06 moles of where is it? Of cyclohexene. Okay, so I'm just going to put SH. Tell you what, let me just I'll write it all out. I'll write the formula out. C6H10. We know we're going to get that many moles because it's a 1-to-1 ratio, and if we have 0.06 moles of this one, then we're going to have 0.06 moles of this one. So we need to now, if this is the amount of grams per mole, then that means if we had 1 mole of that, then if we had 1 mole of this, it would be 82 grams, but we don't. We've got 0.06 moles. So to work out the mass, which is the equation up here as well, it's going to be the moles multiplied by the mass of 1 mole. So the mass is equal to this 82, the molar mass, multiplied by the mass, which is not 1.8. Don't get confused with that. We're talking about not the mass. We're multiplying it by the molar mass, which is 0.06. Okay, we should hopefully find that it's quite a bit more than 1.8. Okay, so let's find out what it is. Okay, so that ends up being 4.92 grams. So again, this is the mass of, let's use some highlighters again. This is the mass of cyclohexene if all the cyclohexanol reacted. Now, as you can see up here, after purification, 1.8 grams of cyclohexene was collected. So clearly we didn't get all of this. This is what we're going to get. So you're going to find out a little bit more about how to use that number in a later question. In fact, it's going to be in this question. That's what we're going to do now. So maybe I will add this to this video here. Okay. So calculate the percentage yield. Well, the percentage yield is going to be what percentage of the theoretical amount that we could have got did we actually get. So we got this. We could have got that. So how would we use that information to work out the percentage yield? Okay. So yeah, we take the amount that we actually got, which is the 1.8 grams. So that's the amount. Yeah, that's the amount that we got once we purified it. 1.80 grams. The amount that we could have got, the largest amount we could have got, is 4.92 grams. So that is this fraction. This would be the amount that we got as a fraction of the amount that we could have got. And then to turn it into percentage, we just times it by a 100%. Okay, so what's that then? Yeah, good. So rounding up to three significant figures, 36.6%. Cool.